All right, let's begin. The final exable is the Collidable. The Collidable has the standard registry and deregistration process of all the other exables, though this one also uses templates to do its work. This is because we can't know for certain the name of every single class that the user is going to try and define. They're going to define them as whatever they want. So by having a type name C, we are allowing this to be as robust as possible and letting the user define whatever classes they wish for their collisions. Beyond that, the standard registration deregistration, which is handled with an attorney here. So we pass through the registration and deregistration to the appropriate register and deregister commands. Over to here. So the game loop request is this. So sending the collidable group, this determines what the ID is. So to do this, we get the collision manager through the pass-through and get the collision ID based on the type name. So this get collision ID, this uses a local static function. This makes it so that it's updated once, and then every time we call this function, it refers to the same one. So if the frigate calls this at first, then it gets the ID of 0, then the axis gets 1, and cube gets 2, etc. Anytime either of those call this get collision ID in the future, they will always get the same number. So frigate 0, axis 1, frigate calls it again, they would get 0 once more. Once we do that, we set the group type for the ID. So we go over here into our vector array over here. We have it set as at a default size value, and we push it into this ID, and that creates a new collision group if it's not already created. The collision groups over here has registry and deregistry, which going back to the collidable, we have our assert guards, and the registry and deregistry happens over here. So when we register it, this is where we get our set and get of the list reference. So this is where we set it, which once again, we are back at the attorney, passing it all the way back to our collidable. And when we wish to deregister, we are erasing at the list reference we just passed in above here. Just going all the way back to here. So this list ref is set from this function that was passed through by the collidable group, and then we get it when we're ready to delete. When the collidable is deleted, we delete the B-sphere and both of our registration requests. Excuse me. So for actually handling these, inside any given scene, we set up collision pairs and collision selves. So when we set these up, it calls this templatized function within the scene to go to the manager and set up the collision pair between the two classes defined within that scene. So hopping back to here, setting the collision pair, we will look in the group collection for the ID value at class type 1 and class type 2. We will create a collision dispatch using the template of those two types, and then push into our test collection those two pairs. The test collection is a list of collision tests. For collision self, we do the same thing, except we have one group instead of two, so we just fill it out with the same class twice, and then we push that onto it as well. This collision dispatch over here is collision dispatch right here. This collision dispatch has a thing to send the collision to the two different collidables. As a default thing, giving people a heads up if it's not done properly. When it is done properly, however, it goes to this templatized version of that class, where we will static cast ourselves to the two object types that we defined earlier, so like frigate and axis, for example. And then we tell those objects that it's time to collide. For the volumes to quickly cover this, currently we only have B-sphere volumes, so when it's time for testing, shit, I'm all over the place. For testing purposes, go over to the process elements. When it's time to process the elements, which is done in the scene, it's done as the first thing after the request broker. We go through our collision test and try out every single collision. So for collision pair test, this is just a default parent function, parent class, excuse me. For the collision pair, it's a collision test between the two groups and the given dispatch. So here is where we do our B-sphere intersection that we have the math for. So if the intersection is tested properly, so over here for the intersect, for the B-sphere, we have the math tools B-sphere to B-sphere intersection. Get the centers, get the radii, find the vector between the centers, add up the radii. If the radii squared is greater than the dot of the vectors, then congratulations, you have an intersection. So going back to this collision pair, this is where the templatized call of send collision for the dispatch is done. So over here we have this as the one for when it's not done properly. But when we have the collision template and we have the send collision, this is where we have our static casts and telling the objects to collide. For collision self, this one does it slightly differently because we only have one group. So instead of having the two in the pair, how we have the two lists and they're just incrementing themselves, making every possible combination. For the self, we start at the beginning and then we also start at the end and we work our way towards the middle. So by doing this way, we make sure every combination is tested. The same object isn't paired against itself, so frigate 1 is not tested against frigate 1 ever. And also, we do not fall off the list. So this makes sure every combination happens without falling off the list. And then once again, we do our B-sphere intersection. If it succeeds, we send the collision. And that is that stuff. So for the actual collidable, whenever the world data is updated, we should be updating the collision data as well. So when I go over here, update collision data, all the way down here. So whenever I update the inputs to update the world, whenever we update the world, we update the collision data here. So this updating it will compute the data for the B-sphere. So when we compute the data for the B-sphere, we take the collision models center and radius. We multiply our center point by the center of the vector, and then we take the matrix, multiply by that. For the radius, we take the mag of any of the vector rows and multiply by the radius. Because we assume uniform scaling, it doesn't matter if we take the x vector, y vector, or z vector and do the mag. So long as we do one of those, we will get the same result. And then the B-sphere is B-sphere is B-sphere, B-sphere to B-sphere. So if I were to run this, if I were to go over to here, we can see that we have collisions with frigate 0, 2, and 4. If I were to shift myself to go backwards, you can see that now I'm colliding with just 2, and then I'm with 2 and 4, 2 and 2 and 4. If I go backwards, we can see now I'm colliding with the axis. While I'm colliding with the axis and I swap scenes, you can see that no more frigate interactions are happening because there are no more frigates. And that's it.